So the weather in Austin is still pretty miserable. Now, I'm not complaining. I know some of you are in much colder climates, just stating the fact that that has me locked up in the garage and doing some build work. And this is actually a build that I'm going to be covering in a few weeks. It's the Firefly 6 from Bird's Eye View. Adam Sloan there was kind enough to send me the airframe. Now I went ahead and purchased what they call the high efficiency propulsion bundle. And the propulsion bundle comes with higher power motors. These are the T-Motor MT3506 650 kV. You can see we're in a Y6 configuration. So this guy has both vertical takeoff and landing capabilities as well as forward flight. So it's going to be really cool. But where I am is I'm currently wiring up the power distribution board. And with the normal motor setup, you wire everything up in parallel. But with the high efficiency propulsion bundle and these Tiger motors, you actually need to wire up your LiPo batteries in series. Your batteries actually go in each one of these slots. And what I'll do is demonstrate using the PDBs for this setup, setting up our batteries in both series as well as parallel. Now here you can see the PDB, have it taped to the table. Now normally you stack these with nylon spacers, but this is just easier for illustration purposes. We have two 3S 5,000 milliamp hour LiPos. And just taking a close look at the PDBs, you can see we have our positive and our negative, where both negative terminals coming off the XT60 connectors connect to the ground plate, and the same for the positive. So what that essentially gives us is these two are wired up in parallel. And by doing that, our voltages across here are going to be the same. They're going to be roughly 12.4 volts if these are fully charged. And our current capacity will double from 5,000 milliamp hours to 10,000 milliamp hours. So we have our batteries now connected in parallel. You can see that we have our DC voltage set at a 20 volt range, and I'll go ahead and take a measurement. And you can see that we're close to 12 volts. These batteries are not fully charged. Now everything is wired up in series, so what that will do is that will double our voltage. So now we'll have a 6S LiPo equivalent, and our current capacity, the 5,000 milliamp hours, will stay the same. And what we have is positive coming out to negative, negative going to positive on our other LiPo, through the battery and out to negative. So if we take a measurement, which we'll do here in just a second, across these, we should see the equivalent of a 6S LiPo. But before we do that, I just want to demonstrate, because it's really easy to visualize it when you think about two batteries. These are AAAs. You have your positive, negative connected, and what that does is basically double our voltage output when we're in series, just like we have wired up with our LiPos. Now let's take a voltage reading. I'm going to jump from our 20 volt to our 200 volt maximum, just because we know this will exceed 20 volts. And you can see that we're at 25 volts. So that's how you get these guys wired up in series. And what I'll do is I'm going to stack these power distribution boards using the nylon spacers, get them in the Firefly 6, and in a few weeks I'll definitely be doing an extensive series covering the Firefly 6, talking about the build and just how it handles in the air. I'm pretty excited about the vertical takeoff and landing capabilities as well as forward flight. But I thought it would be an appropriate time to talk about series versus parallel wiring of your LiPos. If you guys have any questions or comments, please post them below. And until next time, thanks for watching.